I guess I'm live. Okay, fine. Let me edit the title. It's 7, right? Yeah. Let's see how today's contest goes. It's a practice contest. The beta phase from AtCoder. I have to note down the things, the topic which I am weaker. I'm audible, 7, right? Yeah. Let's see how today's contest goes. It's a 2, 1, go. First question, Takashi is walking along a mountain trails aiming for the Sumit. There is n checkpoints number 1 to n along the trail and temperature at the checkpoint is Ti degree. Okay. Start from checkpoint 1 and pass through all the checkpoints to reach the Sumit. Okay. At checkpoint I, if the absolute difference in the temperature from the previous checkpoint is at least T, that is this. So we say a sudden change occur at checkpoint I. How many sudden changes are there? Okay, we take input T and K, total number of checkpoints, N and K, cool. We take the input of all the temperature, previous is T of 0, and let me declare answer to track. We have to start from 1, 2, and here we'll check this condition. If ABS of T of I minus T of I minus 1 should greater than equal to K, and we increase our answer, and that's it. Yeah, let's submit and move to the next question. Yeah, it works. Let's move to the second question. In the town where Takashi lives, there is a straight road with n points arranged in a line. Okay. For each section between adjacent point I and A, whether it is closed or not, it's represented by integer wi. When wi is 1, then the section is closed due to the construction, or it is 0, then we can pass, freely travel. That's fine. Takashi has a M construction completion permits. Before starting the journey, Takashi can select up to M closed section, use one permit each. A section on which a permit is used, closure lifted, and before freely travel. Okay. So actually we can think like this is how, right? So somewhere construction is going on, so it is block. So we use magical power to remove this. something like that. So starting point is 1. He can travel between adjacent point any number of time, both direction. When the section 2 use on the chosen optimally, find the number of points Takashi can reach from point 1. Okay. 1, 2, 3, 4, 5. So he can use here and here. Currently at this point, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. It's like this. It's free. 1, 2, 3, 4, 5, 6, 7. Right. And it's a free. Here it's not free. Here it's free. Free, not free, free, not free, not free, it's not free. This is also not free. And this is free. So currently here can use here. Use this magical power here. You can travel, use another magical power and you can travel. This is what, right? We can use here 1, 2, 3, 4, 5, 6, 7, 8. That's it, I guess. We like greedily we can travel. Int n and m magical power. C and answer is equal to 1. Right? If and let me take input. If x is equal to 0 and m is greater than 0, then m minus minus and answer plus plus. Right? We can do here. If m is greater than 0, m minus minus, else break. See out answer. This should work. No? Let's debug. Oh, haven't taken input. Yeah, it's working. Let's hope it pass. No, why wrong answer? Did I understand the wrong? Number of points that Takashi can reach from point 1. Why am I feeling sleepy? Construction completion permits. See, if we encounter one, anyhow we need to use our permit, right? Where is that? It's 0, 0, 0. And we have one. So we can't go like beyond this. Anyhow, we need to use here, right? Or what else I'm missing? I am feeling sleepy. सारी रात आंखें भरता पल पल तेरी. Why this? Why this is happening? If I once I'm getting live audience, that would be fun to attempt a code test. This is a practice contest, right? It should be good someone like if we have interactive audience. Or I should change my stream timing. Although this is a practice contest, I can change stream timing to night. Hmm. What I am missing? Crazy. Something I'm missing then. Something I'm missing. What I'm missing. Oh, it's n minus 1, right? Wow, I did a mistake. Why? This is what a normal person doing coding and a pro person doing. This is the mistake we do regularly, right? It would be fun and learning also. Like the mistake I'm making actually shows like this should not meant. This mistake should not meant to happen. See, we get a nice AC, just a small mistake. Takashi manages n piggy banks. Okay, each piggy bank is number 1 to n. That's fine. Each piggy bank I contain a IN. From now, Q operation will be performed in order. Okay. Operation 1 is This deposit X yarn from this current amount in a what? In each of the piggy bank increased by yn. An integer p is given. Check the amount in piggy bank. This is a segmentary question. This is a segmentary question, right? Because otherwise we'll get TLE. I know like it can be done using segmentary. Seriously? What is this? Four? Four input? Wait. N and Q. We're having N banks and initial money. Q queries, right? And query can be of type 1 and type 2. 5, 4. This type 1 has 3 integer, type 2 has 1 integer. Okay. So for this, what we'll do? Brute force won't work here. Difference array should work, but when we constrain on query, oh, we have to update a range. And we have to update a range. So question is asking there is some A1, A2, A3, A4, something like this. A5. Update some X to all of this number. Update some X to all of this number. Update some X to all of this number. Update some X all of this number. And tell me what is the value of A4. These are the nice, like, feeling too sleepy. These are the nice use case actually. See, this concept we frequently need in a contest like one. I have to know how to do this question. I know how to answer this question if it is like if the second query is the last query, but we'll get till then. Crazy man. I want to see the count. Oh, we can't. Why? Yeah, we can go, right? It's a master. Crazy version. Crazy profile. Let's think. Can we? So whenever we create a difference array, whenever we'll get the type 2 query, we answer like, does this helps? What if there is 10 to the power 5 type 2 query? Think we have to calculate like, does this affect? Okay, type if type is 1 L R X L R and X. It's a 0 base or 1 base. It's always 1 base. And what we'll do here is A of L plus is equal to X if R plus 1 is less than N and A of R plus 1 minus is equal to X. This is actually difference array. It's help. See, this is also a nice concept. Like when I learn this is like this hits crazy to me because see, it is useful when you have something like this. We have like let's say everything is 0 and someone told you add 2 to add 2 from 1 to 5. Look, index 1, 2, 3, 4, 5. Then someone tell you add minus 5 from 2 to 6, 2 to 3, add this like you have lots of operation and then someone asks you what is the value at what is the final value at third index. Then you can answer in order of 1 after doing some pre-processing. The pre-processing is this, like it says from like you have to add 2 from 1 to 5. So what you will do, you will add 2 to. So it's logical also. See, you need to include this 2 from 1, 2, 3, 4, 5. So you add 2 here and minus 2 from this sixth. So while doing a prefix sum, so see 2 is added here, 2 is added here, 2 is added here, 2 is added here, 2 is added here. So when you compute the prefix sum of this, so what you are doing 2 plus 2 minus 2, it's overall it's 0. So this is how it is. This is the fine, but I am not sure about operation 2 because it will hit the TLE. C out A of index. Failed. Why? Why it's failed? Somewhere I haven't taken input or what? X. Something is weird happened. Debug A. Debug A. Okay, print actually. Oh, something has happened here. Wow. Haven't take the input. 60. 105 and 10. This is not good. 30, right? This is 30, right? Q. Index is 2. It's this. Oh, it's 60. How come it's 60? Oh, this is a prefix sum. But this is how it should be. Difference array. Got it. Vector of int difference of n comma 0. Difference. Again, we are hitting the error. Why? This is how it should be. See, this is how it should be. Oh, I have to go. I have to go. I should shift my stream timing at evening. But this should work at least. This should work. This should work. Why it's not working? Mm. Okay, let me debug. What's difference is giving here? Zero. This is making any. Oh, okay. See, we're getting nice answer. I have to clear the difference. It will hit TLE then. This should hit TLE. No, I don't want TLE. This is a pure TLE code. I don't know why I'm writing. Or maybe I am not focusing on time limit things. I don't know. I don't know. I don't know. I don't know. Why a wrong answer I'm not expecting? At least TLA should find why wrong answer. Why wrong answer should get TLA instead of wrong answer. Did my sample pass or I think my sample pass, right? No, not even a sample passed. Why it should pass? I'm idiot making a silly mistakes. Now this will give TLE. Let's see. Should give TLE. At least I'm not getting TLE here. If there is no TLE here, then we'll get AC. Yes. Come on. See? Oh, we are at 73. We'll get TLE. They will increase the test cases. Yeah, see, we're getting TLE. Now we need to learn this concept. They don't give, they said you can use AI, but instead of this, they should give hints. That anyone knows how to solve this question. Maintain and update in log n, that should work. Then it's a segment tree, right? We try segment tree. Let me ask my, can we update a range in log n time in segment tree? Oh, lazy propagation. This is advanced concept for me. I have to learn. See, we're getting nice TLE. Let's move to the D question. Assign a task to distributing cakes to n children. Children's a number this. Okay, currently that has AIK. Same number of cake, okay. They surely ask. Takashi can perform the following operation any number of times. Choose two adjacent children and move one cake from one of them to another. However, it is not possible to. Okay, that's fine. If someone has no cake, then we can. That's valid question. The total number of cake does not change through the operation. It's possible to add. It's not possible to add new cake. Okay, so the count of cake should not change. The minimum option required to make number of cake equal. If total number of cake is not divisible by n, then it's impossible to achieve the goal output minus 1. Okay, this seems a good question. One, two. See, if we give one cake, three, four, five, six. Why this seems easy to me? Like, first we'll check the sum is divisible by n. If it is not, then minus 1. Otherwise, every student should get uh, to sum divided by count. Okay, okay, okay. Binary search on answer. Yes, this is binary search on answer. And again, question is, I will check. How will check? You will always propagate this to this side or this side, right? For this, you will see the nearest. We can do right in order of one. See, if this net 2, obviously you'll get from here or from previous. Always. If it is extra, we'll move. Yes. Yeah, it's because anyhow we need to take it from here to here. Yeah. Can do binary search on answer. Pancakes. Cool. Firstly, we'll find the sum if sum mod and then simply cout -1 and return. Otherwise, don't even need binary search, right? Need is sum by n. This is not correct. So for this, we will move continuously. We don't have anything here. Hmm. Wait, if we're moving from this side, if for example we have to distribute 3 to all, but this child has 5. Anyhow, this 2 extra thing will go. Hmm. If A of I is greater than need, then extra plus is equal to A of I minus need, right? Answer plus is equal to extra. Else A of I is less than. Then condition arise. How much? Hmm. Can, okay, we need two extra. Extra 2 is equal to 0. Okay. See, this is something nice I have in my mind. Let me implement if it is works. See, how much is more want? How much it's want? It want need minus A of I. If extra one has want, then we simply minus extra one minus equal to want, right? Else it doesn't have. So we'll minus want minus is equal to extra one. Extra one becomes 0. Okay. So in extra 2, we have to borrow from somewhere else. This much. Right? Here, what we'll do here is if extra 1 is greater than equal to extra 2, then extra 1 minus is equal to extra 2, and extra 2 becomes 0. Else extra 2 minus is equal to extra 1, and extra 1 is equal to 0. Answer plus is equal to extra 2 also. Pass, pass. Why it's failing? See, need is 2. Okay, cool. Need is 2, 2, 2. Debug extra 1, debug extra 2. Let's see. Extra 1 is 0, extra 2 is 2 because we have to borrow 2. Okay, okay. Then again this is happened. This is not true. Plus होगा. That should be plus here. Yay, we are on right track. Cool, cool, cool. This is right, correct? should work. This should work. Yes, this is working. So what actually I did, I have 9 minutes and I'm for sure I'm not able to solve this. So what should I did here? Let me explain. Let me explain. Somehow I need to learn the trick. This is some trick is using here. Okay. Otherwise the today's content is pretty good. So what I did, see, something we know like we have sum. The sum should divisible by x, right? This is this many cake. Let's just see. We have to distribute everywhere. So we our final target is we need to make everything C. C number of cakes, everyone, right? So there are few cases. This initially this has B number of cake. We have to make C and B is less than C. So we need to get some cake. That is this one. Say this is the case. We want some cake. This is store in want. So what we did, does some extra cake we already have from here? Oh, this is looking bad. Yeah. So if we have and we are already like for one shift, let's say we have few extra cake. So the cake should travel from here to here. It need one, two operation. So let's say some extra ATX1 cake is also I'm adding here. See, whatever extra cake it should propagate to this point. So I'm propagating and I'm adding like this should anyhow add in our answer, right? We have to propagate from here to here. So what let's say 5 cake is extra. Then propagating 5 and again 5. So it is 5 by 10. Already we have included in an answer. Let's say this should be Z, then want is Z. So now Z cake will won't propagate further, right? So what I am doing here, uh, want if so I am extract like want I'm minusing Z from want. I'm making 0 and I'm confused. Where are we at? Yeah, we want something Z cakes, right? If if we have enough cake here, right? Let's say we want 3 and we have 5. That what I checked here. Then we simply remove that 3 from here, then 2 cake will propagate. And if we don't have enough cakes from here, so what we'll do, whatever the cake, let's say we have 2 cakes, so we'll take all the cakes, right? Then now we no extra 1 cake is present here. So now we want extra 2. Extra 2 is the count we will get from this side. So now the count is 1, right? Because we have 2 cake and we want 3 cake, so we use 2 cake. So we left with 1 cake. So from somewhere in the future we want 1 cake. So we start calculating. We want 1 cake. We want 1 cake this way. So we are adding that to our answer. So this is how it is. So that's all for today. I want to see how I can eliminate TLE. I am quite happy with TLE because I know it's not a optimized code. So yeah, that's it for today. Bye bye.